Hello again, my friends. If you are here for the very first time and you don't already know, I'm Islam Shaban with PC-based PLC programming using TwinCAT3 tutorial. This is exactly where you want to be to learn more about the TwinCAT3 and how to program a bit of PC-based PLC. In this episode, we will create our Hello World project and walk through the software interface. So grab your coffee and let's start. First, open Visual Studio. And every time you create a project, you need to open Visual Studio because, as I mentioned before, TwinCAT3 is already integrated with Visual Studio. Hit Create New Project. Here you can find all the templates based on which workload that you selected to install in Visual Studio. Now we want to create a TwinCAT project, so we're gonna search for the TwinCAT template. You're gonna find these two templates, TwinCAT PLC Project and TwinCAT XAE Project. You have to select the XAE project, not the PLC project. And maybe you're wondering, why is that? As we're gonna write a software PLC, so selecting a PLC project sounds more logical, right? To understand this well, we have first to understand the software architecture of TwinCAT3, knowing how it actually works. I'm not gonna bother you with all details of the TwinCAT3 philosophy, but I just highlight the main concept. TwinCAT3 consists of two main parts. First, Extended Automation Engineering, or XAE, and this is the development environment for TwinCAT3 software, where you can create, configure, and compile your TwinCAT3 projects. It includes the System Manager configuration and programming, where you can write your program using the IEC 61131 standard or C++. Of course, this is for the real-time application. And for non-real-time application, you can use C#.NET. TwinCAT is not only integrated with Visual Studio, but also integrated with MATLAB. The second part is the XAR, which is stand for Extended Automation Runtime. The TwinCAT3 runtime offers a real-time environment where TwinCAT3 modules can be loaded, executed, or administrated. After compiling your program, Visual Studio creates binary files and transfer it to the XAR so they can be executed. XAE can communicate with the XAR via ADS protocol. We gonna talk more about the ADS later in this tutorial. On the other hand, the XAR can communicate with sensors and actuators using the field bus interfaces, for example, EtherCAT. One of the advantages here is the XAR can be installed on the Windows PC as well as BIC of operating system. When you download the XAE software, it includes the XAR part, which is mean if you install the XAE, you will be able to run your compiled software locally in your PC. So you don't need to purchase actual PLC hardware to develop your software. This is one of the advantages of TwinCAT3. As in the development phase, you can use your local PC as a PLC and test your software before deploying it over a real hardware. And that's because, anyway, big of PLCs are just ordinary PCs with some customized settings. In this tutorial, I'm gonna use my local PC to develop and test the TwinCAT software. Alright then, back to the Visual Studio, select the XAE template and hit Next. Here is asking you to give a name to your project. This name will be the solution name, or you can give your solution a different name if you wish. I'm gonna name it TwinCAT Tutorial and hit Create. It opens an empty project as you can see. Your project theme could be different than mine, so if you want to change the theme, you can do this. From Tools tab, select Options, select the Generate tab, then here you can change the theme color to your preferred one. Alright then, let's walk through the software interface. In the left side of the screen, you can find the solution tree. It starts with the System Manager. It's the place where you can configure and adjust the system properties. Double-click on the System node will open the System window with a number of configuration tabs. From here, you can choose the target system. In case you're using an actual PLC hardware, you can search the network from here to find and select the PLC to deploy the code on it. But in this tutorial, I'm using my local PC, so I'm gonna keep the default setting to local. The licenses node, you can renew and manage and add the licenses for TwinCAT and its tool. You have to renew the licenses every 7 days. It's free of charge. It's only requesting you to enter a CAPTCHA. The real-time node where you can manage the real-time settings. Later in this video, we will dig deep into how to do so. But now, let's take a fast walkthrough for the most important tabs. Tasks, where you can add and manage the tasks you use in your system. Most of the time, tasks configuration is closely related to the real-time configuration. The motion node is where you can add and manage the motion module, such as CNC and NC. If your system includes motion-related objects like motor and axis. PLC node is a quite self-explanatory. This is where you can create a PLC project and write your PLC code. Is where we actually will spend most of the time in this tutorial. C++. Here you can create the C++ project and program your PLC using C++. Later in this tutorial, we will cover this part in depth. I/O node is where you can add and configure the field bus and devices which is the PLC uses to communicate with the outside world. I mean the sensors and actuators. Basically, the I/O node is the place where you do the hardware configuration to the PLC. Okay then, let's create a PLC project. Right-click on the PLC node. And this window is asking you to select which PLC template you want to use, the standard PLC template or the empty PLC template. We're gonna select the standard PLC template. And most of the time, we're using the standard template. Then give the PLC project a name. Let's say Hello World and hit Add. The standard PLC template contains some folders as you can find it in the project tree. Those folders are not mandatory for anything. They are just for organizing the code, so you can change them with the way you prefer to organize your code. But according to the template, those folders are created based on the file type, or let's say the object types. At the moment, I'm gonna walk through these folders and explain its meaning briefly. So let's start with the POU folder, which stands for Program Organization Unit. POU is mainly the heart of your code. Basically, it's the functions and function block, also the program blocks of your code. The standard template is already created a program block for you called main, and it's the entry for your code. We will elaborate on this more in the next video. The GVL or global variable list, it's where you can declare the global variables. And if you are a former user of Siemens PLC, for example, the global variable list, you can consider it the equivalent of data blocks there. DUT, which stands for data unit types, and that's mean you can define your own data type, for example, structure and enum. The equivalent in Siemens, as you can guess, is UDT. Also, you have here the references. It's the libraries that you can add and use to your code. The template already adds some for you, like the TwinCAT2 standard library, which is include many useful basic blocks, such as timers and counters blocks, for example. Finally, the viz or visualization. Actually, it is a nice feature to use if you want to create basic visualization. It is useful if you wanted to simulate or test your code, but I do not recommend it to use it to build your HMI, as Beckhoff already has a powerful web-based HMI. And last but not least, the references task, which is responsible for how fast your PLC code will run.
Creating tasks and learning how exactly the real-time control works is such a big and exciting topic. So, in the next episode, we will dive deep to explain and discuss the real-time configuration and task configuration as well.